Okay, so we have a box with a square base. Okay, so that means the base of this box, if it's square by the definition of a square, they have the same, the sides are the same distance. There's no top on it, right? It's an open top. And the volume, let's just write that down, the volume has to be 4 cubic feet, right? So a lot of times we need to just fit a certain amount of stuff inside something like maybe you need a quart of oil or whatever. How do you make the thing, how do you make the container to minimize the cost? And think about it. You want to do that. Even if you save 1 penny per container, if you make millions of these containers a day, that's a lot of money that a company would save. So anyways, let me continue. The cost to build the box is $1 per square foot for the bottom, $2 per square foot for the sides. And we want to find the dimensions that will minimize the cost. Well, that means we need an equation for the cost. Well, what is the cost? The cost is the number of square feet on each side times the cost per square foot. Yeah? So for the bottom, the total number of square feet is x times x, which is x squared. But then we want to multiply that by how much does it cost for each one of those square feet. Well, for the bottom, it's $1 per square foot. Then we got to add to that the cost for the sides. Keep in mind the top is open, so there's 1, 2, 3, 4 sides. So that's, we got to multiply by 4. The cost of each side, well, now we got to figure out what is this height here. Well, the volume of let me start by calling this y, because we don't know what that is. The volume of a rectangular solid is length times width times height. So the volume is x squared times y, but we know that has to be 4. So if we solve for y, we can see y is 4 over x squared. So let me plug that in here. 4 over x squared. So now what is, as I said, all right, so the cost, we got to now add the cost for the 4 sides. What is the area of this side? X times 4 over x squared. What's the area of each side is the same. X times 4 over x squared, and it's the same for each of the 4 sides. So the total area is 4 over x squared for each side, but there's 4 sides. So this is the total number of square feet on the 4 sides. What is the cost for each one of these square feet? We got to multiply by that. The cost is $2. So let me put that $2 here. And here's our cost equation. And it is a function of just one variable. So we can take the derivative. We take the derivative of that because that is what we're trying to optimize, or in this case, minimize the cost. So let me clean this up a little bit. So I'm going to take away the units of dollars. So we have x squared. 8 times 4 is 32, and let me write that as x to the negative 2. So when we take the derivative of the cost, we get 2x squared minus 2 times 32 is 64, x to the negative 3. So setting this to 0, we have 2x squared minus 64 over x cubed is 0. Let me, I don't think I'm going to need that anymore. So just by inspection, by looking at this, we can see one of our critical numbers is x is 0. But again, we can throw that away because if x is 0, you aren't going to have any, there's not going to be a base, right? So that can't, we don't need to worry about that critical number. So let's solve when it's 0. When I add 64 over x squared to both sides, we get this, over x cubed, I mean. Multiply both sides by x cubed, we get 2x to the 5th equals 64. So we get x to the fifth is 64 over 2, which is 32, x to the fifth. So x is the fifth root of 32. And what is the fifth root of 32? Well, the fifth root is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So x is 2. So what are the dimensions that minimize the cost of this container? The dimensions are 2 by 2, and 4 over 2 squared is 1. So 4 over 4 is 1. So the dimensions are 2 by 2 by 1, and that will minimize the cost of making this particular container.